Atoma.
Atoma, right. So Democritus basically was the first person, at least on record, to say, I think everything's made of these little tiny particles called atoms. So 460 BC, Democritus. All right, so you're not necessarily writing any of this down, you're just paying attention because you should have it from yesterday. So Democritus had the first concept of atoms, okay? All right, who's next?
John Dalton.
John Dalton.
Oh, you know what, I forgot. I'm gonna draw this here. So Democritus kind of thought the atom was like this solid, tiny sphere, like a marble. So that's what that is. All right, who's next?
John Dalton.
1808, right?
Yeah.
I had the shadow on the board to remember that there. John Dalton, what did he say?
All matter is made up of atoms.
All matter is made up of atoms. Good. All matter. So if you have this, again, you don't need to write it, just pay attention. All matter made up of atoms. What's that?
Should we draw that circle?
Yeah, if you want. That's not one that's, you know, they're not going to ask you questions about that, but it's good to know. All right, what's next?
Joseph John Thomas.
J.J.
Thompson.
Thompson.
Not Thomas.
Or whatever.
18 what? 98. What'd he do? Discovered the electron doing what?
The purple plum pie thing.
Discovered. That's why I wore this. What's the motto?
Plum pudding.
Did you not just hear me yell purple plum pie thing?
So irritating.
I want you to do it, Jake.
Purple
Can you take it
plum
off,
pudding.
Good.
Thanks.
You're welcome.
All right. So, J.J. Thompson discovered the electron by doing what?
Purple pie plum pudding.
No.
Plum pudding.
No.
Yes,
pudding.
say it.
Oh, he something with a negative particle.
I can't say
Yes.
it. It's the
Wait,
same
he
guy.
found that atoms could sometimes.
What experiment did he do?
The golden sheet of
No.
Yeah.
Rutherford.
Plum pudding.
Stop saying plum pudding.
That's all I wrote down.
He did the plum pudding.
Jake, did you get the experiment? Start with C,
Plum pie pudding.
A, T. Yes, that spells cat. Cathode ray. Does that ring a
What?
bell?
No.
They said that
No, it
yesterday.
didn't.
Why do I think of
No,
cat
it
pudding
didn't.
say that?
No, it did not.
Now you have to update your notes. Write this down.
I wrote
Yeah,
down
because you didn't
everything.
teach us right. Clearly.
I wrote down everything.
Cathode ray experiment.
Purple pie plum
Leave
pudding.
room for this.
If they didn't say it, then I guess I'm losing it. But I thought they said
You
that.
should go back to the video. and
I'm gonna
say-
show you this experiment today. Not me personally, but a video of it. I don't have this thing.
Wait, then what is that?
What?
What is that then?
I'll show you later. Okay, so we discovered the electron with the cathode ray experiment. I'll explain that later. And what was his model?
Plum
The
pudding.
plum pudding,
Purple
right?
plum pudding.
So the plum pudding model. What did he say?
Well, it was positive,
Good, big positive.
and then
What was
there was
this?
just a bunch of
Yeah.
electrons.
Well, yeah, but what is this?
The purple pudding pie was really positive.
Just relax over there.
Is that an atom?
Or negative electrons.
Yes. So the whole atom, imagine, is like a bowl of pudding. That's what this is. What's
pie.
stuck in the pudding?
Electrons.
Right. Plums. And those are the electrons. Those are the electrons. Right. So stay with me. Enough with that for now. The electrons are stuck. They're not moving around. So that was the big problem with this. But we should probably label that. That's an E minus. That's an electron. All right. That's Thompson's contribution. What's next, or who's next?
Ernest Rutherford.
Rutherford.
Oh, he did the gold foil experiment.
Right. Rutherford, 1910. Gold foil experiment. Gold foil experiment. All right. What did he prove about the atom?
That they have nucleus.
Good. Atom has
Nucleus.
a nucleus. Don't say that word. It gets everybody confused.
What?
Because that's like cells in biology in your body. We're not talking about cells. These are way smaller than cells.
Oh,
Okay. Atom's as small as it gets. So that's confusing.
true.
All right. Nucleus, and what's the charge?
Positive.
Positive. So the nucleus is positive. Nucleus is positive. Okay. So every atom in the world has a positive nucleus. So the nucleus is positive, so atoms have nuclei, and then that nucleus is positive. Anything else about the gold foil?
Oh, 1 in 10,000 hits.
Stop touching him. Stop touching him. It's not okay.
He's only.
Anything else about the gold foil?
1 in 10,000 hits.
No.
Okay, so that was Rutherford. We're going to talk more about the gold foil tomorrow. I'll show you the experiment, again, a video. But that's Rutherford. All right, who's next? One more.
Niels Bohr.
Bohr. What year?
1913.
1913. So there's overlap here with these two. What did Bohr say?
The electrons confined to
Small
constraints.
nucleus, and then the electrons orbit around the
He said electrons orbit
which is
the
wrong.
nucleus, which is wrong.
He's the wrongest of all.
So cross off the word orbit, but, so it's written, but put it next to it just so you know it's wrong.
I just wrote wrong.
So electron orbit the nucleus on levels. Remember we said layers, levels. That is correct. There are layers, there are levels, so that's correct, just not the orbiting part.
Call it an orbital. Why did they do that if the orbit is wrong?
Because they thought it was right.
But it was wrong.
And the orbital that actual word came out way before, like now, present day. So that's why. I know. Wait till we get to bonding and forces of attraction, and there's a force called hydrogen bonding that's called a force, not a bond. But the name bond is in the name.
I don't want to get
James.
that. I don't hear a lot.
Okay. Okay, so I need you to sketch this somewhere. I don't care where. Positive nucleus with some levels surrounding it. All right, that's the Bohr model. So sketch that somewhere, preferably near where you wrote Bohr. Okay, that's the Bohr model. So again, on these levels, you have electrons, and they're contained to those levels. So there's a lot that he said that is correct. Okay, so very smart guy, and a lot of it was right, just not the orbit part. So that brings us to the most current model, which is called the what?
Electron cloud.
The electron cloud, good.
Wave mechanical.
Wave mechanical, good.
The Apple Cloud.
Are they the same thing?
Yes, there's 3 names.
That's unnecessary.
Current model. Okay, it's called one of 3 names. The wave mechanical model. So these are new notes. The wave mechanical model, or the quantum mechanical model. Does anyone know what quantum means? It means energy, like a bundle of energy. Quanta or quantum is a bundle of energy. You're going to see soon that electrons can gain energy or they can lose it, and that's a quantum, and that involves light. So we'll talk about that. So wave mechanical, quantum mechanical, or the electron cloud. Electron cloud model. Now the electron cloud model is not what you will see on the Regents. They will not call it that. They will call it wave mechanical or quantum mechanical. Electron clouds like the layman's terms, like the simple terms, right?
Yeah.
That's why I remembered it.
Okay, so remember it's like a positive nucleus with a whole bunch of dots around it, and those dots represent what? The electrons. Right, and they're more dense around the nucleus, and why is that?
Because
They're attracted to it. Opposites attract, right. Electrons are negative, positive nucleus. Okay, the only thing you need to remember about the most current model is that electrons are found where?
outside the nucleus.
Good. Specifically in?
The levels.
Good. Specifically, what part of the level? Annika has a problem with it?
I just said.
Orbital.
fun.
Annika has a problem with some. A lot.
What'd you say, Trevor?
I just said, I
Alright.
said orbital.
Orbital. Good job, Trevor. Orbital.
Oh, yeah.
So, this is what we need to write. The highest probability of finding an electron is in an orbital. Underline orbital. That's essentially like the definition of the current model. I know that sounds weird, but you have this whole cloud of electrons buzzing around like lightning bugs or fireflies, whatever you want to call them. And if you want to find one, you have to look where they are. They're in the orbital. So the analogy I call it the electron hotel. Kind of corny, but it helps. You have all these floors. Now people go stay in the hotel, and you stay inside the rooms. So the rooms in the hotel are the orbitals. So if you want to find somebody in a hotel, yes, I'm sure there's people in the lobby, obviously, but we're going to say they're in the room. So you're going to find someone in the room. If you come into school, you want to find a student, yes, they could be in the hallway, but the best spot in the rooms, in the classroom. So electrons are also in their own rooms. They're in the orbital. All right? Questions? So where would you not look for an electron? If you could, okay, right in the nucleus, right. So that's the concept. Okay?
That word's confusing me.
Nucleus.
Well, she was saying like in lab, it was like nucleus.
Shut up!
Hey, don't call her out like that.
No.
I was saying it right. And
She's the one that's on your side in lab. So,
Yeah, I know.
Yeah, I'm the only one not anti-Kieran, and I watch your stuff.
No, Adam is anti. Well, yeah, no, he isn't. He's on my side. So is Trevor. Jake's half on my side.
I think Jake's all right.
Kristen's just.
All right, let's not go down that path. All right, lights, please. Let's watch the cathode ray experiment.
I was not in the video.
It was not in the video.
Purple
I
pie.
don't believe it.
Can we like prove it?
Purple pie from thing.
If I'm wrong, Trevor will do 20 push-ups.
Okay.
What am I doing?
I'll put that shirt on my. It's gonna have a purple blob on it.
I told you I'd eat Uncrustables anymore.
Why can't I take it on this time? No.
Ah, here we go.
Uncrustables are for me.
Are we proving that I'm wrong?
It's gonna be right here, right?
Actually, no, I'm right.
Well, pumping.
Ha! Trevor, practically
What
20.
happened?
I guess he did. I guess it's not in the video.
I was right for once.
Yeah, for
Yes,
once, don't be used to it.
Caitlin. Yes,
Wow,
Trevor.
you guys are right.
Trevor, you
All
have
right.
to do 20
Trevor, you
push-ups.
got to do push-ups. I'm sorry.
Yeah, I'll do when I get home.
All right. All right. So,
At first I thought that was you.
it's not me. Plus, this guy has pleats. I don't wear pleats. So, you don't know what pleats are? Does anyone know what pleats are? Oh no, he's flat front. He's good. All right. Now, this is some teacher, but it's a good video. This thing is called a cathode tube, cathode ray tube. All it is, he's going to explain this, but I'm going to say it anyway. In here, it's an evacuated space. What's that mean? Really, nothing, not even air. Okay? He's got a battery hooked up to the cathode and the anode. You guys know what those are? Ends of a battery, right? So let's say this was a AA battery. Okay, so you have your little bump there. That's your plus. That's your minus. The flat side. Yes, a AA battery.
Yeah.
Wake her up, please. Okay. So this is the negative. This is the positive. This is actually the anode. That's the cathode in a battery. So that's the terminals on a battery. YouTube, just pay attention. So this is the cathode. That's the anode. It's like the black and the red on a car battery. So those are electrodes. So he's got that hooked up, and you're going to see a beam of electricity going through this tube. That beam of electricity is a beam of electrons. And he's going to take a magnet and bring it near the beam.
Uh-oh.
What do you think will happen?
It'll go right to the next.
What was that? The beam will do what? Yes, it'll either be attracted or repelled. Okay? This is what Thompson did a long time ago.
This is a cathode ray tube. What it essentially is
Just pay attention. He has a pretty normal
there are
voice.
no gases inside this glass tube. The only thing we have are two electrodes, one's called the cathode, the other's called the anode, and a fluorescent screen in the background. Coated with some type of fluorescence.
All right, I guess we can't handle that.
No, I
So, the beam of electrons are going to be going through here. There it is. So that's a pure beam of electrons. It's pretty cool because there's nothing in there for the electricity to pass through.
It's like
If I had, you know that Tesla coil, that taser thing I had?
Yeah.
If I had it right here and it was on, I couldn't just start zapping you through the air.
You'd
okay?
be a wizard here.
It wouldn't happen. Now, lightning can obviously travel through the air, but that's because it's a massive amount of electricity, and that's a little different. It's kind of like an arc. Like if you were to hold that Tesla coil close to this pole, it would arc and touch the pole if you got close enough. So lightning's different, but most of the time, electricity needs something to travel through. Okay, wire. Okay, so this is cool because there's nothing in there, but the electricity is traveling through there, and that's called a cathode ray. So he's going to bring the magnet near it, and you'll see what happens. What is the problem? Karen.
He's just.
Yeah, all these people. Caitlin, what's the deal? Can you focus? Try and focus here.
I'm good.
He's going to bring a magnet near the electrons here, and if you hold one pole, like the north or south, it should repel. If he flips it, come on, buddy. Okay, so if you hold the magnet a certain way, you see the electrons are repelling. If he flips it around, what's going to happen?
It's gonna attract.
Right, it's going to attract to it. So, way back when Thomson did this, didn't know what the charge was, but he knew if a magnet affected it, it must have some kind of charge. So the beam is being pulled towards the magnet. So this is the cathode ray tube experiment. That's all it is. Okay? All right, back to our notes now.
But how does it?
Lights, please. Lights, please. Okay. All right. Cathode ray. You guys need to focus. Stop with whatever is funny, fine. But come on. Cathode ray tube. What did Thomson do? Thomson determined that electrons had a charge. Electrons had a negative charge. Eventually, not right away, but eventually, Thomson determined that electrons had a negative charge due to the cathode ray being attracted or repelled by a magnet. Attracted or repelled by a magnet. So that was it, except I think he probably used a magnetic field, which may or may not have been from a magnet. I don't remember, but so this is how they figured out the electron had a negative charge. So why am I stressing this? One question, I forget how long ago, it was a while ago, on the Regents. It said, multiple choice, which of the following particles were discovered using the cathode ray tube experiment? 90% of the students got it wrong. I felt bad because, yes, I teach it every year, but I didn't really specifically make a big deal about it, so now I do. So cathode ray and electron, you need to have those two kind of synced up in your head there. So cathode ray and electrons, that's how Thomson figured it out. Okay, now we have a couple minutes, I'm going to use it. I'm going to go back to another video here. I want to do one at a time. And it is not the heating curve one. Lights, please. Getting a workout.
Wait, what's the last slide? Okay.
Being attracted or repelled by a magnet.
What's that?
I'm not sure if I like this bracket, actually. Okay. Did I turn this back on? No. All right, so this is the gold foil experiment, and we need to understand radioactivity a little bit before we talk about this. So, back to microwaves. Microwaves move through the air, hit your food, they heat it up. This, come on, come with me. There we go. Okay, this is a radioactive source. They're going to shoot it at the gold foil. So radiation can heat things up. It can also mutate cells, but it's also a good way for scientists to use it when you hit other atoms with it to see what happens. So this is a radioactive source. This radioactivity is not microwaves, it's not gamma, it's alpha. So this is alpha particles. Who did this experiment?
Oh, Ernest Rutherford.
Ernest Rutherford, right. He shot alpha particles at the gold foil. Who remembers what most of them did?
It went right through.
It went straight through. Watch what happens here. When they start shooting this thing with alpha particles, most of them are going straight through. We'll talk more tomorrow.
I want to see that one down south. Where is it?